Okay, so continuing and finishing up the problem in 10.3, the B example of the last problem. So here we want to find the points on the cardioid, r equals 1 plus sine theta, where the tangent line is horizontal or vertical. We found earlier in part A a formula for dy dx. So we got the dy dx was cosine theta sine theta plus cosine theta times 1 plus sine theta over cosine theta minus sine theta 1 plus sine theta. So in order to find horizontal and vertical tangents, we need to know when is the derivative 0 and when is it undefined. So this boils down to saying where's the numerator 0, that would give a horizontal tangent, and where's the denominator 0, that would give a vertical tangent. If they're both 0, we don't know, it's indeterminate, so we'll have to deal with that as it comes up. So let's set the numerator to 0, cosine theta sine theta plus cosine theta times 1 plus sine theta equals 0. To solve this equation, note that there's a common factor of cosine theta, so I'll factor that out, leaving me with sine theta here, 1 plus sine theta from here, and so now I could simplify the inside of the parentheses here, giving me cosine theta times 2 sine theta plus 1 equals 0. So now it's either the case that cosine of theta is 0 or 2 sine of theta plus 1 equals 0. In other words, so this one would become sine of theta is negative 1/2. So the possibilities here we have theta is pi over 2 or 3 pi over 2 for cosine of theta equals 0. For the other one, we have that theta is 7 pi over 6 or 11 pi over 6. Just if we're going from 0 to 2 pi. That's how we graph the curve. If we go beyond 2 pi, it's just going to repeat itself anyway. So for the other one, we want to know when is the denominator 0. So cosine theta times cosine theta minus sine theta times 1 plus sine theta equals 0. Might as well write cosine theta as cosine squared theta, and I'm going to go ahead and distribute that negative sine theta. So I have something like this. It's difficult to solve this equation in its current form because we have these different trig functions and it's not factorable. So what we could do is let's change cosine squared theta into 1 minus sine squared theta. And now we have everything in terms of sine theta. Note that negative sine squared minus sine squared is negative 2 sine squared theta. So just writing this quadratic equation in descending order, I see that it's quadratic. I've got a square, a first power, and a constant. Typically with quadratic equations, we like to see the first number be positive, so I'll just divide everything by negative 1. And with these specific numbers, I can factor. I could say this is 2 sine theta minus 1 times sine theta plus 1. Indeed, if I FOIL, 2 sine theta times sine theta is 2 sine squared theta. 2 sine theta plus 1, I'm sorry, 2 sine theta times 1, that's 2 sine theta. Negative 1 times sine theta, that's negative sine theta. Well, 2 sine theta minus sine theta is positive sine theta. Negative 1 times 1 is negative 1, so we factored it. Then either 2 sine theta minus 1 is 0 or sine theta plus 1 is 0. Therefore, the sine of theta is 1/2, or the sine of theta is negative 1. And so theta is pi over 6 or 5 pi over 6, or theta is 3 pi over 2. So, like we, for the most part, have found all the horizontal and vertical tangents. Pi over 2, that's a horizontal tangent. At 7 pi over 6 and 11 pi over 6, there's horizontal tangents. At pi over 6 and 5 pi over 6, there's vertical tangents because the denominator is 0 and the numerator is not. But at 3 pi over 2, we see this mutual 0. So we have an indeterminate form for the slope of the tangent line. So let's address what's happening. Let's address and find out what's happening at 3 pi over 2, and then we'll summarize what are all the ordered pairs where we have the horizontal and vertical tangent lines. So at theta equals 3 pi over 2, m, the slope of the tangent line, is indeterminate. So let's figure it out by using a limit. In other words, what's happening as theta approaches 3 pi over 2? What's happening to the tangent lines? So the limit as theta approaches 3 pi over 2, technically we should say what's happening as we approach 3 pi over 2 from the left, in other words from quadrant 3, and what's happening to as we approach to the graphs we approach 3 pi over 2 from the right, from quadrant 4. We'll see what kind of answer we get and see if that's going to really matter. So if I put in my derivative, I'm going to put in the factored forms of my derivative, just easier to work with. So cosine theta times 2 sine theta plus 1 over 2 sine theta minus 1 times sine theta plus 1. Now, we know this is going to give 0 over 0, so I'm going to use L'Hopital's rule. Okay, so I'm going to say the derivative of the first, so that's negative sine theta times the second, plus the derivative of the second, so 2 cosine theta times the first, cosine theta. Excuse me, same thing in the denominator, cosine of the, derivative of the first, so that's 2 cosine theta, derivative of the second times the first, derivative of the second is cosine theta, Now, if we imagine putting in 3 pi over 2 for all these, hopefully, now it'll make the limit work out nicely. At 3 pi over 2, sine is negative 1, so I have negative negative 1. 2 sine theta, so that's 2 times negative 1, so negative 2 plus 1, that's negative 1. Cosine at 3 pi over 2 is 0. And I have 2 of them, so I just wrote 1, 0. Downstairs, 2 times, 0, because that's the cosine of 3 pi over 2. Sine theta plus 1, so that's sine of 3 pi over 2 plus 1, negative 1 plus 1. Again, cosine of 3 pi over 2, that's 0. 2 times the sine of 3 pi over 2, so that's 2 times negative 1, so negative 2. Minus 1 is negative 3. But we can see the denominator is 0 and the numerator is not. The numerator looks like it's negative 1 over 0. Now, if we were being more careful, we would see that as we approach 3 pi over 2 from the left, we actually get a positive infinity, and as we approach from the right, we get a negative infinity. The point is we're getting an infinity. Okay, so a line with infinite slope is a vertical line. So we have a vertical tangent at 3 pi over 2. So now let's summarize the thetas where we get the horizontal and vertical tangents, and then we'll list the x and y coordinates. So we have horizontal tangents when theta equals pi over 2, 7 pi over 6, and 11 pi over 6, and we have vertical tangents when theta is 3 pi over 2, that we just found, and then also pi over 6 and 5 pi over 6. So these are the thetas, but we want to know what are the points on the graph where this happens. So at pi over 2, well, what, x is equal to 1 plus sine theta times cosine theta. So 1 plus sine of pi over 2 times the cosine of pi over 2, so that's 0. Okay. Y is equal to 1 plus sine of pi over 2 times the sine of pi over 2, and so what, 1 plus 1, so that's 2, times 1 is 2. So we're going to have a horizontal tangent at 0, 2. Now let's look at 7 pi over 6. So I have that x is 1 plus the sine of 7 pi over 6 times the cosine of 7 pi over 6. The sine of 7 pi over 6 is negative 1/2. The cosine of 7 pi over 6, negative square root 3 over 2. So in the parentheses I've got 1 minus half, and then it's times negative root 3 over 2. So I'm looking at negative root 3 over 4. For y, I have 1 plus sine of 7 pi over 6 times the sine of 7 pi over 6. Well, I mean, we've already done these calculations for the most part. The parentheses will again be 1/2 because it's 1 minus 1/2. Sine of 7 pi over 6 is negative 1/2. So I'm looking at negative 1/4. The other place where I had the horizontal tangent was 11 pi over 6. So x is 1 plus the sine of 11 pi over 6 times the cosine of 11 pi over 6. The sine of 11 pi over 6 is negative 1/2. The cosine of 11 pi over 6 is square root 3 over 2. So in the parentheses I've got 1 minus half. So I'm looking at square root 3 over 4 for my x coordinate. For y, 1 plus the sine of 11 pi over 6 times the sine of 11 pi over 6. So again in the parentheses I have a 1 minus 1/2 and then a negative 1/2, giving me a negative 1/4. So I have horizontal tangents at 0, 2, negative root 3 over 4, negative 1/4, and positive root 3 over 4, negative 1/4. So that takes care of my horizontal tangents. Next, let's look at the vertical tangents. Well, when theta is 3 pi over 2, x is 1 plus the sine of 3 pi over 2 times the cosine of 3 pi over 2. Well, cosine of 3 pi over 2 is 0. Y, we have 1 plus the sine of 3 pi over 2 times the sine of 3 pi over 2. Well, sine of 3 pi over 2 is negative 1, so this says 1 minus 1 in the parentheses. so also 0. At pi over 6, we're looking at x as 1 plus the sine of pi over 6 times the cosine of pi over 6. The sine of pi over 6 is 1/2. The cosine of pi over 6 is square root of 3 over 2. So here I'm looking at 1 plus half, that's 3/2, times the square root of 3 over 2. So I'm looking at 3 square root 3 over 4 for my x coordinate. For y, I'm looking at 1 plus the sine of pi over 6 times the sine of pi over 6. We already know this is 3/2. Sine of pi over 6 is 1/2. So I'm looking at 3/4. Lastly, at 5 pi over 6, so x is going to be 1 plus the sine of 5 pi over 6 times the cosine of 5 pi over 6. The sine of 5 pi over 6 is half. The cosine of 5 pi over 6 is negative square root 3 over 2. 1 plus half is 3/2 times negative root 3 over 2. And so I'm looking at negative 3 root 3 over 4 as my x coordinate. For y, 1 plus sine of 5 pi over 6 times sine of 5 pi over 6. Again, we know that 1 plus sine of 5 pi over 6 is 3/2. And we know that the sine of 5 pi over 6 is 1/2. So I'm looking at 3/4 as my y coordinate. And so I have vertical tangents at, well, let's see, 0, 0. 3 root 3 over 4, 3/4. And negative 3 root 3 over 4, 3/4. And so now we found all the horizontal and vertical tangents on the graph of 1 plus sine theta. Goodbye.